This is Dr. Sajja Suneel from Data Science Department, working at IARE as an assistant professor in data science. Today, I'm here to discuss you about introduction to controlling hardware and sensors. What exactly controlling hardware and sensors? In our principles of Internet of Things, we are having a particular things which are connected to Internet. In that, it's very essential to control the specific hardware as well as the sensors which are emerging in the IoT system. Now we'll have a look what exactly these things are, what are the different kinds of hardware components and what are the different kinds of sensors which are existed in a IoT system and how we are going to control those particular hardware as well as sensors, how we are configuring, how we are knowing, how we are extracting the data from sensors. All these things will play a major role in an IoT system. Now we'll have a quick view what exactly the things are. Before going into the subject, I just want to tell you what exactly these principles of IoT was. Have a look. Principles of IoT, where we are provided with a comprehensive understanding for the fundamental concepts such as which are related to Internet of Things and the different kinds of technologies and different kinds of applications which are used by n number of people in day-to-day life. IoT is playing a major role in human as well as in the industry sectors as well as in multiple areas. IoT is playing a big role nowadays, and here students are going to explore different kinds of principles which are underlying through this particular IoT with the help of this architecture, networking, sensors, data management, security as well as the emerging trends. Have a look, guys, what exactly the particular course is aimed for, what are the objectives which we are going to achieve, what are the objectives which we aimed at this particular course was. Here in this particular course, you are going to get a comprehensive understanding about these IoT concepts as well as the different kinds of IoT technology and different kinds of applications which are presented in IoT. And also, our intention about this particular course was to equip the students with a practical skill in hardware interfacing as well as sensor integrations as well as the IoT system development. Different kinds of IoT systems are there in our day-to-day life also. Whenever we are in our organization, we are having an IoT environment which is security surveillance, as well as whenever we are at home, we are having an IoT home automation. Whenever we are at industry, there will be an IoT system. Everywhere, whatnot, in every sector, this IoT is playing a major role. For that purpose, this course is aimed for the students to tell about the network management. What are the different kinds of cloud computing techniques which are existed, which are using in this particular IoT system. Along with this, we are fostering the critical thinking as well as the problem solving abilities for the students to improve their designing and implementation skills in IoT solutions across multiple domains. As I told you, in IT sectors, in home automations, in personal systems, in organizations, like this, multiple domains are there for our IoT. And what we aimed for, what are the course outcomes after learning this particular course, what we are going to get here. After successful completion of the course, student able is to design and implement different kinds of IoT systems, such as including an appropriate hardware components and designing efficient communication protocols and integrating sensors and actuators into the system. There is a point, sensors and actuators into the systems, how we are going to integrate these two things in an IoT system. For any kind of IoT systems, these sensors and actuators will play a major role. Sensors are the things which is going to sense and which is going to start recording the data. Whatever the data which is recorded by the sensors are going to be, with the help of actuator, we are going to react. For suppose, take a real time example. Being as a human, how much important is eyes and ears and our mouth. How much important it was. With our eyes we are able to see, and with our ears we are able to hear, and with our mouth we are able to talk, right? And here for human, these three things will place as a sensor. By observing the certain person, our through our eyes are playing as a sensor. And by by hearing some sound, we are going to hear some noise, and ears are playing as sensors, right? And accutators, what accutators are? Take a same example here. For suppose something is coming in front of us, we try to object by using our hand unintentionally, not intentionally, unintentionally. We try to block the thing, right? True? Yeah. Like that, accutator is the one who is going to help us. Along with that, we are going to analyze the IoT requirements, what exactly that particular IoT environment requires, whether it is suitable architecture or not, whether this technology is sufficient to that particular organization or not. Is there any kind of improvement which has to be taken by that particular IoT developer? And along with this, here today, after completion of this course, they are able to successfully design the data pre-processing techniques, like for suppose, take an exact thing. From sensors I am extracting some data which is recorded throughout the day. From that particular data, I am going to evaluate the things which extract the valuable insights from morning to evening. What are the exact valuable insights which are presented? What was the data gathered through that particular sensors? Like this, a data pre-processing technique is required, and also it helps us to inform decision making, and based on this analysis of that particular results. And also, after successful completion of this particular principles of IoT, we are able to implement the security measures. How the security measures are, like, is there any cyber threats? Is there any proper authentication is provided for the data which is encrypted or not? And also, is there access is given to a certain person or not? Access controlling mechanisms, like this, multiple things are going to be learned by us as a successful outcome of this particular course. Have a look what exactly in this particular things we have in this particular principles of IoT. Today I am going to discuss a topic which is controlling hardware and sensors. This was comes under the third module, and the preferred textbooks are Arshdeep Bhagya and Vijay Madisetti, Internet of Things, and also getting started with Raspberry Pi, which is written by Matt Richardson and Sean Wallace, and also Raspberry Pi Cookbook, Software and Hardware Problem and Solutions, which is written by Simon Monk. And what are the contents which are going to be discussed in this specific module? Today, I am going to discuss about controlling hardware, connecting LED, and buzzer. These are the three topics which I am going to discuss with you today. And before entering into this particular concept, I just want to brush up what exactly this particular topic was: controlling hardwares and sensors. Why we need to control a hardware? Why we need to control a sensor? For suppose, let's assume, I'll tell you with a real-time example. We are having a security surveillance system which is existed in our organization. In that security surveillance system, there will be a camera which is existed in your class or else in the corridor. For that particular camera, there is a particular sensor which is existed inside of that particular camera. With that particular sensor, motion sensor, let it be, take an example with, if any motion has been observed in front of that particular camera, then automatically it will sense, the sensor is going to alert the actuator to start record the data. Like this, sensors are going to play a major role. For that particular purpose, we need to control the sensor, and along with that, there will be a particular hardware which is existed in that camera. That hardware has to be controlled by us by writing a specific program. For suppose, take a real-time example. Most of you guys are aware about the smart LED lights which are going to function by itself without the man usage. Like for suppose, treat it as motion detection LED light. For suppose, whenever you are walking inside the corridor, automatically it starts switching on the light. Whenever no motion is detected in that particular floor, automatically the lights are going to be shut it down. Like this, the things are going to be designed with the help of this particular controlling hardware and sensors. What are the topics which are presented in this controlling hardware and sensors? Have a look. The first one, the first concept in this was controlling hardware. And coming to the second concept, as I told you, connecting LED lights. How we are going to connect, what are the materials required, how the connection is going to be given, how by writing a program, C++ program, how we are going to make that LED functionable. And in the same scenario, working things, everything will be explained in detail at the time of discussion. Along with that buzzer, same procedure. Switching high power devices with transistors, controlling AC powered devices with relays, controlling servo motor and speed control of DC motor, unipolar and bipolar stepper motor sensors, light sensors, temperature sensors with thermostats, voltage sensors. Here I need to discuss from here onwards, the things are going to turn with sensors like controlling servo motor sensors, light sensors, temperature sensors with thermostats, voltage sensors, A to DAC sensors, temperature and humidity sensors, DHT11, and motion detection sensors, which I discussed you with a brief example at the starting of introduction. Wireless Bluetooth sensors, level sensors, USB sensors, embedded sensors. Like this, multiple kinds of sensors are used in our IoT system. Now, I just want to tell you, in our day-to-day life, daily we are observing multiple sensors in the things which I just had a quick view now. See, observe this. How many of us have seen these stepper motor sensors in our stepper motors? Bipolar, unipolar stepper motors are there. In those motors, a sensor is going to be fixed to detect the particular motor functioning. And along with the light sensor, when the light has to shut down. For suppose I'm walking in front of a particular light, automatically the light has to sense the motion of that particular person. Automatically, if I am studying, automatically it will produce like studying mode. If I am in party mode, the light has to be converted into party mode. Like that, the motion capturing has to be done by that particular lens light sensor. Coming to the temperature sensor is the one which is going to predict the current temperature which is presented inside the room and outside the room. Like this, temperature sensor will be helpful. And coming to the voltage sensor, which is going to detect how much voltage is capable, how much voltage is producing. Are we using above that particular voltage? Are we use below that particular voltage? For suppose a voltage is required to run a specific organization, 230 volts. Above that 230 volts, if you reach it, will gives you an indication in form of a alarm with the help of this particular voltage sensor. And coming to the temperature and humidity sensor, as I told you, temperature is going to be detected, humidity is going to be detected, which is presented in the air. And along with the motion detection sensors, as I told you, whenever you are watching in your home, walking in our organization, automatically by using this motion detection sensors, the fans, the lights are going to automatically switch on itself and shut down itself. Why? Because to reduce the human intervention in the switching on the lights and switching off the fans. Most of us are lazy nowadays. Everyone has to accept this. Why? Because people are very much interested to switch on the fan, but people are less interested to switch off the fan. It was true. We have to accept. If we use this motion detection sensor mechanism in switching on the light, switching on the fan, switching on the AC, automatically most of the power is going to be saved. And along with this, wireless Bluetooth sensors, which are playing a major role in our smart gadgets as well as why? Because everyone nowadays are using iPods, which is a wireless Bluetooth sensor, and level sensors, USB sensors, embedded sensors. Like that, every device is having our IoT system in it. So have a look. Now we will enter into the things what exactly the objectives of this particular module was. These objectives are divided into two different types. The first one is data acquisition and monitoring. Coming to data acquisition and monitoring, which plays a major role. from the IoT devices. We need to grab the data, and that particular data has to be continuously monitored. The first point, see here, gathering informations. Sensors are the things which is going to collect the data from the environment to the system itself, where the data can be anything like temperature, pressure, light levels, motions, chemical composition, whatever the type was, it will be considered as data. How we need to control these sensors? We need to know what kind of data is collected and what level of precision was existed in this data. These are the things which comes under controlling. And coming to the second one, track and analyze. Continuously, we need to monitor the sensor data. Why? Because a continuous tracking is going to change time by time, and also there will be a number of trends which allows us to make understand how effectively the system is functioning and how anticipatedly we are identifying the problems with potentiality. These are the things which are existed in data acquisition and data monitoring. Now, the second one is system automation and control. What system automation was and what system control was, how we are going to do these two things in detail. The first one is influence the environment. There are certain hardware components such as actuators which are controlled physically by the environment. Take an example, including turning on lights, opening valves, starting motors. By using sensor data as input, we can do this thing automatically. As I told you, for suppose to switch on this particular electronic gadget, I need to press a button which is placed over here. For the same thing, if it is automized by recognizing my face, the motion detection sensor which is presented here in front of the gadget, it is going to automatically switch on automatically. So no need of human intervention to switch on this particular electronic device. In the same way, seize this example for turning on the lights, for opening the valves, for starting motors. If I place the sensor data as input, automatically these three things will turn into automation. That is what our IoT beauty was. And coming to the next factor, which is optimized performance. What optimizing performance was? Here, basically in our control systems, we are using sensor data to adjust the actuator settings in real time. Why? Because sensor was the thing which is detecting the things and actuator was the thing which is reacting to it. For suppose take a real time example, you guys are listening to the class. If I stop telling the scenario, you are going to shut down your PC and you are going to went off, right? In the same similar way, sensor, the voice which is coming out from my mouth, if it stopped, it is going to be muted. In the same scenario, for suppose, treat a real-time example. You and your friends are chit-chatting by sitting in front of you. Suddenly, your friends raised their hand. What your reaction was? What your sensors indicates to your brain? Automatically, by seeing that reaction, your eyes are the sensors which is going to send a request to your brain. Automatically, actuator was the one who is responding and alerting your hand to object that particular thing. True, right? In the same similar way, sensors are the things which are used for adjusting the settings in real time, which is going to evaluate the automatic things and also improving user experience. In many cases, most of the things controlling hardware, which is more convenient and more user-friendly experience. For suppose, see here, a thermostat, which is automatically adjusted by heating based and sensors reading for the temperature. These are the objectives, and have a look what are the outcomes which are going to be taken away after successful completion of this particular module. First, let me tell you a thing here in the outcomes. These particular outcomes are based on the application of IoT, which we functioning. For suppose an IoT system, home automation can be taken as example, which increase the efficiency and also which improves the safety, which is used for enhancing the decision making and also for greater convenience and comfort. These are the four different outcomes which are going to be generated after successful completion of learning about this particular module called controlling hardware and sensors. Coming to the first one, increasing efficiency. Automating tasks and optimizing processes can save our time, energy, and resources. So, automatically the efficiency is increased. And coming to the second factor, which is improving safety. By controlling the systems, we can prevent accidents by based on the reactions of the sensors readings. Automatically, safety is going to be elected. For suppose people are working in mines, if there is some prediction, some sensor mechanism which is set out in a coal mine, it is going to predict the nature's alert. Automatically it will alert you, so and so thing is going to happen within so and so time. So automatically people will get alerted, so that it increase the safety method. In the same way, enhancing decision making. Whatever the data which is collected by the sensors is going to provide you valuable insights, and that valuable, based on that valuable insights, we are going to analyze, and by that report we are going to take some decisions on that particular data. Like that, it will enhance our decision making. And the last outcome was greater convenience and comfort. This greater convenience and comfort will be known to you by automatic systems, which can create a more comfortable and user friendly environment. What was the thing? It can create a more comfortable and user friendly environments. These are the outcomes which we are going to get. As I told you today, from these particular topics, I am going to discuss with you three things. One is controlling hardware, another one is LED, and the third one is buzzer. Right? What are the three things? Controlling hardware, connecting LED, connecting a buzzer. These are the three things which we are going to discuss in this particular session in detail. Have a look. Till now I have given a brief intro about how we are going to control these hardware and sensors, what are the different topics which are presented in it, what are the objectives for this particular module, and what are the outcomes we are going to get from this particular module. Till now we have discussed. From now onwards, we are entering into in detail about topic by topic. The first one is controlling hardware. This was the first topic in module 3. See here, controlling hardware, which is a basic fundamental principle in our IoT. We will know how these things are going to function. Take an example first, sensors and actuators. Now I will let you know what exactly the sensors are and what exactly the actuators are. As I told you previously in the previous examples many times, eyes and ears. Simply sensors which can be easily called, easily recognized. These are the eyes and ears of the IoT system. For any kind of IoT systems, sensors are the ears and eyes. For human, take a real-time example. Take ourselves. For human, the sensors are eyes and ears. How we will hear a sound? By with our ears. How we will observe? By seeing with our eyes. If these two are not there, our sensor system is not going to function properly. These are the things which are going to collect the data about the physical environment, such as temperature, light, pressure, motion. Whatever the data is going to be gathered from these sensors are going to be converted into the electrical signal to a device and make us to understand. And what actuators are? Actuators, these are the hands of the and feet of the system. Hands and feet of the IoT systems. These are the things which take that particular processed data and utilize with our common connected physical devices. Examples: turning on the lights, adjusting thermostats, opening and closing valves. Valves are nothing but in banks will have money vaults, opening and closing. For that purpose, actuators are the things. Sensors, which is your input pin. By placing that pin, automatically the door walls are going to be opened. The open walls and closing walls are the part of actuators. Coming to adjusting thermostats, turning on lights, all these are the part of these actuators. Have a look. This is about your sensors and actuators. Now take another example controlling hardware, which is microcontroller and single board computer. Microcontroller with SBCs. Basically, these are very small and low power computers which acts as a brain of our IoT device. See here, which acts as a brain of IoT device. How these are responsible in a controlling hardware and these sensors. These are responsible for reading sensor data and for processing the data and for making decisions based on the data which is generated by the sensors and for sending control signals to the actuator. These are the things which is responsible for doing these four things: reading sensor data, processing the data, making decisions based on the data, sending control signals to actuators. These four things can be done by these microcontrollers and single board computers, which are SBCs in shortcut. Coming to the third one, which is communication protocols. As we discussed in our previous sessions, discussing about the modules called IoT communication protocols, there we discussed these particular things. IoT device need to communicate with each other by using a cloud platform. This can be done by using various types of communication protocols such as Wi-Fi, Bluetooth, cellular network, specialized low power protocols like Zigbee and Z-Wave. These are the different kinds of communication protocols which are used in our controlling hardware. Coming to the fourth one, which is cloud platform, which is optional thing here. I just want to tell you how cloud is playing a major role and how cloud platforms are going to be used. These cloud platforms are going to be used to store and analyze the sensor data. Whatever the data which is extracted by the sensors are going to be stored and analyzed in this cloud. And also, it is going to send some control commands to the device remotely and also managing large number of systems and IoT devices. Here, there are some specific points which are going to be achieved by us by successfully controlling the hardware in IoT systems. Those are direct control. The microcontrollers are the direct controllers which are going to be based on actuator and sensor readings or user commands. Excuse me. Coming to the next one, which is cloud-based control. In this cloud-based control, sensor data will be sent into the cloud and which is analyzed by the control commands. How it is going to be analyzed? Sensors are the things which is sending your data to cloud. And after receiving that data, it should be analyzed. Then only we can take some decisions, right? That is what here cloud-based control is going to take. What has to be instructed to actuator. The entire things can be done in a fraction of the seconds. But behind the skin, see, observe, cameras are the one. By using the motion sensor is electing in an electrical wave and it sends to actuator. Actuators are the one who is responding to the data which is sent by the sensors. This is how cloud-based control will function. Coming to the next one, mobile app control. By using this mobile app, users can easily control the IoT devices through a specific mobile app which is presented in their electronic gadget, which is going to send n number of commands to the cloud platform where we are relying them to a specific device. These are the cloud platforms which are really optional examples of hardware control in IoT. See the examples. There are some examples which are listed down here for our better understanding. Have a look. Smart thermostat that adjusts the temperature based on sensors reading. Smart thermostats which are used in our temperature sensor readings. See, these smart transistors are going to adjust the temperature based on sensor readings. See, for suppose I have seated in my house. The room temperature was 34. By based on this particular reading, I just want 24 to sit very comfortably. So automatically by based on reading, this thermostat, smart thermostat is going to adjust automatically to 24. Whatever the temperature is presented outside, doesn't matter. These smart thermostats are going to adjust the temperature by based on our sensor reading. That is how our smart IoT is. And coming to the second one, smart lights, which are going to turn on and turned off by controlling remotely. And coming to the next one, wearable fitness trackers, which are going to be used humorously nowadays by n number of people, which is going to track our monitor heart rate and what are the steps which has to be taken, what are the prevention methods, and how many calories I have burned for the day. Like this, everything can be taken, can be noted down by using these wearable fitness trackers. And coming to the next one, industry automation systems, which controls and monitors the control machinery. And by understanding these particular principles, you can successfully see how hardware control is essential in our IoT device to interact with the physical world, which is going to provide us how the functionality of automation will be done. For this specific purpose only, controlling hardware is required. Got it, guys? Now, we'll move to the next one, which is connecting LED. What this connecting LED was? What LED? Light emitting diode. What it will do? It is a fundamental building block which is connected to many IoT projects by providing a simple visual indicator. What simple visual indicator? LED is a simple visual indicator. Here we need to know how to connect this LED by using a microcontroller in a specific IoT systems. What are the materials which are required to control this particular sensors? How to connect this LED? Now we'll see. The materials required: breadboard, jumpers, LED. You can take any color. Resistor 220 ohm is common value in LED, and microcontroller board like Arduino, Uno, and Raspberry Pi kit. We require these materials to connect an LED, right? And now have a look how the connections has to be taken. First, you need to identify the LEDs. Why? Because LED will have a longer leg, which is positive anode, and a shorter leg, which is negative cathode. By using these things, most of the LEDs are having longer light as well as shorter leg, which is positive cathode, negative cathode. Positive anode and negative cathode. By consulting this LED datasheet, if unsure, this is how we need to identify the LEDs. The next one is connect the resistor. Insert the resistor into breadboard. Connect one leg to the resistor and two free row on the breadboard. This is how a resistor has to be connected on breadboard. And next, connecting LED. Insert the LED into breadboard. Make sure the legs do not touch each other in the same row. In a breadboard, for suppose breadboard will be in this format, which will be a white color. There are dots like this where the things has to be placed in it. Now, if I place a LED, if I kept one leg here, I have to place another leg here. We need to make sure no two legs have to be placed in a same row. If these are connected, then automatically the things will be destroyed. And now, how to connect a positive anode, positive lead. The longer lead is a positive anode, as I told you in the initial state itself, and the shorter node will be a negative cathode, and this has to be connected to the free row or breadboard. And how a negative lead, which is a cathode, negative lead is a cathode, and the shorter leg of the LED has to be connected to the ground pin. In this breadboard also there will be a ground. Here the things will be written: this is ground, this is some line, this is some line, this is some line, and this is some. We need to connect that particular and cathode to negative to ground properly. In this line only the things has to be connected. And the next one is connecting to microcontroller to power. Most of the microcontrollers, as I told you, microcontrollers are the one which is doing the power during as well as specific board documentation, and the power requirements can be done by using these microcontrollers. These are the steps which involved in connecting a LED. Now our crucial part, we need to program this microcontroller. For that particular purpose, we need to choose a program platform. The programming language and the environment will depend on our microcontroller. For suppose I am performing by using a Arduino IDE, which is a most common platform for our beginners. Here I am writing basic LED control code. Here I have taken a simplified Arduino code, which is a snippet which is turned to be the LED on and off. See here, I have taken a program in C++ and now I am replacing 13 with actual pin which is connected to LED, void setup, pin mode, LED pin output, which leads to LED pin as output, and I close that particular thing, and I have opened another loop, void loop. In this digital lighter, LED pin high, which is if it is high, automatically the light is going to be on, and if there is a delay in 1000 seconds, wait for 1 second, automatically digital write LED pin low, automatically the light is going to be shut it off, and delay, wait for 1 second, and upload the code. Following platform instructions is going to be uploaded to the microcontroller board which is presented in the LED, and observe the LED. If everything is connected correctly, the LED should blink off for every second. Why? Because we have configured the program in such a way that for every second the LED is going to be switched on and switched off. This is how the things are going to be for connecting a LED. For this, an explanation is given to you. The pin mode functions should be configurable by the chooser pin, which is 13. That was the first point. And coming to the second one, the digital write function, which is a voltage on high pin, which is LED light on and LED light off. That is the second one. The delay function adds a pause between turning on and turning off. That is a blinking effect which is going to be observed by us. And the next one is, there is a very basic example which is going to be demonstrated for us by connecting these particular things into a breadboard. You can expand this if you want by using PWM, which is a pulse width modulation, to control this LED brightness, and also reading sensor data and turning the LED on and off by changing colors based on the sensor readings. And also by experimentally, you can give your valuable experience and essential components to n number of IoT projects. Like this, multiple things can be done in this LED connection. Now we'll move to our third topic, which is buzzer. What buzzer was? Buzzer was the thing which is a fundamental concept of output component in our IoT system, and this will be along with the LEDs, which is going to provide us a simple audible way to indicate the events or statuses. Events are statuses. However, a buzzer can be connected and controlled with a microcontrollable board only, same like your LED. Here also we require a materials, breadboard, jumper wise, buzzer. In this buzzer there will be a passive buzzer and there will be a active buzzer, and also resistors. Here there are optionals which we can be used for passive buffers, and microcontroller board, as I told you, Arduino Uno or Raspberry Pi kit you can take for performing this particular experiment. And here in this connection of this buzzer, first you need to identify which type of buzzer was used by us. As I told you, there are two different types of buzzers. One is passive, another one is active. Passive buzzer and active buzzer. Coming to passive buzzer, which requires a DC voltage and resistor to limit current. The specific resistance is going to be dependent on the buzzer voltage rating, which is a common value of 100 ohms. And coming to active buffer, which contains an internal oscillators and requires only a single power connection supply. This is how active and passive buzzers are. And how to connect these buzzers? As I told you, passive connection. First, we need to connect an LED connection with a resistor and then connect one leg of this resistor to a free road on breadboard. And later, that breadboard leg has to ensure we should not touch in the same row. Buzzer, two legs will be there in buzzer also, right? These two legs should not touch in a same row. One leg will be in the upper row and one leg will be in the down row. and also this resistor is having a positive leg of buffer, which is a common, and negative, which is cathode, positive, which is anode, and this buzzer is going to connected a ground pin on microcontroller jumper wire. Like this, passive connection has to be established. And coming to active buzzer, only one leg of the buzzer is connected to the power pin, which is usually VCC, and the other will be connected to the ground by using your jumper wires. As I told you, jumper wires are also taken in the form of materials which we required for making a successful connection of these LEDs and buzzers. And how to connect with microcontroller, how we are going to choose a particular platform. As I told you, Arduino IDE was the common option for beginners. So we'll take that particular thing only. And what was the basic program which is designed for configuring this Arduino board snippet by using C++. See here, constant int buffer pin 8, which is buzzer to void setup, pin mode, buzzer pin output, set the buzzer pin as output. Again, a loop will be written, buzzer pin high, start generating sound. Buzzer pin after a delay of 500, which is 0.5 seconds, buzzer pin low, automatically stop generating sound, and delay will be written every half second. And now upload this platform code into the microcontroller, which is Arduino, and observe the button. If everything connected correctly, automatically for every half second the buzzer will rise the voice and lowers the voice from that particular buzzer. And see how the explanation is given to you. The connection with active buzzer is simpler, which doesn't require any kind of resistor. The code is going to function with LED, which states the controls of high and low. High is for sound and low is for silence. And there is a delay function which gives us a beep sound between the gaps, pass and beep. This is a basic example of buzzer, how the things are going to be expanded. Playing different tones in form of melody by experiencing the digital write commands on off cycles. And also using the buzzer along with the sensors to provide audio cues based on sensor readings, which is a temperature indicator. And also controlling buzzer, which is used by Bluetooth and wireless communication. By incorporating these buzzers in our IoT projects, we can add an extra layer and feedback sound by in our innovative projects which are more interactive and informative. Let me tell you an example for this buzzer. How many of you are having a calling bell in your home? If I switched on that particular calling bell, automatically a melody will be there for the first time. Sometimes some other melody, sometimes some other melody. Like that, it will choose accordingly or by based on the buzzer. The buzzer was the concept which is implemented in that Arduino board. Nowadays, no need to switch on the board. Automatically, whenever someone tries to indicate in front of that particular sensor, automatically an alarm will be presented in a home automation system. Like this, the things are going to be used in our IoT projects. With this, I conclude for the day, and we will meet in the next class with the different hardware devices and how to control them, and different kinds of sensors, how to control those sensors for a better IoT system in detail. Thank you. That's it. We'll meet later.
Like, share and subscribe. Hit the bell icon for more updates.